Right, so basically what we're doing, we've been asked, first of all, the graph is to be translated 2 units to the right and 2 units up to create a new graph. What's the equation of the new graph? What I'd like to do is I'd like to first of all work out what the equation of this graph is. All right, and then I'll fathom out what's going to happen when I move it up and so on. So the equation of this graph, first of all, the asymptote here, whoops, the asymptote, I've got to draw on this, push the draw button, draw. Right, so the asymptote here is falling, heading closer to 0, isn't it? Yep. So this graph has not moved up or down. Okay, so there's no upwards or downwards movement currently. So the equation will be y equals, with no upwards or downwards movement at the end, so plus 0. And I'll just ignore that later. Right, now, what I need to do is I need to find out where is it that the y-axis should occur in every exponential graph. What happens on the y-axis in every exponential graph if it hasn't been moved left or right?
It's the next point is plus 1 above.
Exactly. So that means if I look at where 1 is, as far as height goes on this graph, it's occurring here where x is -1. All right, so that point there, where x is -1, that really is where the y-axis should be, just here. This is the y-axis, ideally for that graph. Okay, so what that means is this particular graph is sitting one place, 1 unit left from where it usually should be. Okay, so this y-axis that for the graph has effectively made the entire graph move to the left by 1 place.
And by doing that, you put it in there?
Yes. Now, we've still got to work out this number here, but the exponent will always be x. Whoopsie, get rid of that share. X is the exponent. That's why it's called an exponential graph, because the x is part of the exponent. To move a graph, to push the graph leftwards, requires us to add 1 to the exponent. Remember, leftwards plus 1, rightwards minus 1. Okay, so opposite way from what you expect. Now, if my axes for this graph happen to be there, and there's the origin there, the place that I get this next value, right, the base of the exponent, that is the point where we have 1 unit across. All right, now if I go 1 unit across here, notice I'm going 2 squares because each of those squares is half a unit in this graph. See how it's going up in halves? All right, so I have to go, this is the point where the graph would be 1. And what's the height of the graph at that point? It is 3. That's the base of that equation as it. So that's its current equation. Y equals 3 to the power of x plus 1, and you're welcome to put that x plus 1 in brackets if you want to. Okay? In fact, probably when you're calculating your answer for this later on, you want to put in brackets. All right? All right, so that there. Now, that's the graph as is now. Now, if I move this entire graph right by 2 places, so let's do this in green. So this entire graph now goes rightwards by 2 units. How does that change the exponent there?
Be -1 now.
That's right.
X take away 1.
Good. So the exponent will be x minus 1 because now it's 1 to the right of the y-axis. The base has changed, not changed, it's still going to be 3 because we're not changing the stretch of the graph, we're just moving it.
Yeah.
All right, still going to have y at the front. And the other thing that's happened is here we've also moved
to the right, up. Up 2.
Up 2. So that changes that plus 0 into a plus 2. So there's the equation of the graph when it has been moved to the right by 2 places and up 2. Okay, fair enough?
Yep.
Okay, now that we know that equation, so it's y equals 3 to the power of x minus 1 plus 2, I can now go y equals 3 to the power of x minus 1 plus 2. There's my formula. Now, they wanted to find what is the intercept for the new graph. Right, so the y-intercept they asked for? So
Yeah.
that occurs when x is 0. Very good. So what we do is we fill in this equation here
I always
with
forget
x
this.
being 0. 3 to the power of 0, take away 1, plus 2. Okay? So the y-axis intercept occurs when x is 0. Y equals 3 to the power of negative 1. Okay? Because that's what 0 minus 1 is. Plus 2. At this point, we could put that into a calculator if we want to. Okay, because I teach year 12, I know that 3 to the power of negative 1 is the same as 1 over 3 to the power of 1. So, but your calculator will do that for you. So if you basically type into your calculator 3 to the power of negative 1, and I'll probably put that in brackets just to be safe, plus 2, and then for EXE, you're going to get the same answer here, which is 2 and a third.